This is the 11th video of my series, Casting Shadows, and this one's about shadows of boxes on the wall. And I want to remind you of my book on Amazon, where the Kindle version is only $5. Let's start with a horizontal pole on the wall and draw the seat rectangle so that it converges to the same vanishing point as the object. And then find the light direction. And in this case, the shadow is vertical. It stops at the green dot. If the light is more overhead, then it lands on the ground and it follows the seat rectangle to the wall and up to the back of the pole. Since the shadow vanishing point coincides with the object vanishing point, three things happen. The shadows follow the seat rectangle, the shadow on the wall is vertical, and there are no shadows to the side of the box. In this case, the shadow vanishing point is different from the object vanishing point. So we have the seat from the tip of the pole. The shadow goes toward the shadow direction until it hits the wall. Then it goes vertically up following this imaginary seat. And when it hits the light, it goes to the back of the pole. If instead the light hits the ground, then the shadow goes toward the shadow vanishing point until it hits the light, and then it goes toward the shadow of the vanishing point for the object. And when it gets to the wall, it goes to the back of the pole. And we see that pattern everywhere. For example, here, the direction is toward the shadow vanishing point, and when it hits the light, it goes to the vanishing point for the object. So three things happen when the shadow vanishing point is different from the object vanishing point. The shadow doesn't follow the seat rectangle. The shadow on the wall is diagonal, not vertical, and there are shadows to the side of the box. So this horizontal pole casts this diagonal shadow on the wall and a little shadow on the ground. And let's see how we can find that. First of all, draw the light ray so the light goes from the tip of the pole to the tip of its shadow on the ground. And the shadow goes from that point to the back of the pole. And we can see that when we draw the seats, the shadow goes toward the shadow vanishing point until it hits the base of the box as if it were extended. And then, even though it hasn't hit the light yet, it converges toward the vanishing point for the object until it hits the light at number 3. Now, another way we could do this is to introduce another vertical pole here so that when the shadow goes toward the shadow vanishing point, it hits the box, it goes vertically up, and we get this point 6, which helps us find this shadow. To find the shadow of this triangle, turn it into a shape that we know, like a horizontal rectangle, and then find the seats of that rectangle. And for each point on that rectangle, we're going to draw lines, light lines from above and shadow lines from below to get these intersections here and here. And then they follow the rectangle in the same direction until they hit the wall, and then they go to both sides of the rectangle like that. And then finally just change the shadow so it relates to this triangle. One approach to shadows on the wall is to find poles that are close to the light and extend them down. And when they intersect the light, that would be the beginning of the shadow. The shadow follows the box until the next intersection, then up until the third intersection, and then it goes to the corner of the box. In the side view, in this case, we happen to have 2 poles that we can use, and then we can find the shadow pretty easily. Now, this one on the ground also has 2 horizontal poles that we can use. Now, in all of these cases, we don't really need the shadow direction. In fact, the only place where we can identify it is here on the horizontal box. Here's a shadow of a box on the wall using a wall vanishing point. And as I described previously, to find that point, you go to the floor vanishing point horizontally across until you reach the edge of the room, and then vertically up until you're level with the light. And that's the wall vanishing point. And it goes through the back corners of the box that are attached to the wall. We have light rays then going through the front corners of the box, not attached to the wall, which I call floating corners. So let's see how this works. Let's try to find this point on the shadow. So the light goes through the front corner. Now let's make this pole here, this horizontal pole, the one that we're working with. So in that case, the shadow goes through the back of that pole to intersect the light right here. And you can see that, for example, number 3 here, we use this pole, the light goes to number 3 on the shadow, and the shadow direction goes through the base of that horizontal pole right here. The shadow of this box on the wall is front lit. In other words, the pseudo-sun is down here, and the vanishing point for the shadows is here on eye level. And here's the box, which is above eye level, so we see its bottom. And it's on the wall, and we want to find its shadow. So we need to draw light rays through the front bottom corners. Then we need to find seats, and the seats go on the floor, and the back seat is right against the wall. And we make sure the perspective of this seat matches that of the box. In other words, they go to the same vanishing point here. Then, to find the seats, the shadow line, we start here with number 1 and go down to the base of its seat, which is number 2. Then it goes toward the shadow vanishing point here, number 3, until it hits the wall. Then it goes up to number 4, and when it intersects the light at number 4, that's a point on the shadow. Same over here with number 5. Go down to the bottom of its seat. The shadow line will go toward the shadow vanishing point, and when it hits the wall, it goes vertically up, and where it intersects the light is a point on the shadow. Let's say this is a box on the wall in front of us, so it's protruding out, and the light is coming down in this direction, and so this side is shaded, and these areas are light. Now, if we want to draw its shadow, we need to find point 3, and the only way we can do that is with the side view. So this side view shows the box on the wall, which it should be, and it happens to have beveled edges. So start with lining up both views, the top and the bottom of both views. Remember, we don't have the shadow yet. And then draw a light ray from number 1, this corner up here, down to the wall. And do the same on the side view. Number 1, the point protruding out down to the wall. And we know where this point is because the light hits the wall there and obviously can't go any further. So we transfer that position to the front view, and where that line intersects the light is this number 3 that we're looking for. Then we don't need the side view anymore. We can go down to number 4, intersection 4, and then across to 6 and to the corner. But we could use the side view if we wanted to check it out. So let's say we have a light ray going from 2 to 4 there, and same in the side view, 2 to 4. Well, it has to stop here on the side view because that's the wall, and you transfer that position back to the front, and there is number 4. The next video is about shadows of boxes on inclines like chimneys on roofs. So we're really getting into the fun stuff now.